Okay, so over here, we're just going to be analyzing some of the definite integral properties. Some of them are very similar to the indefinite integrals. For example, this one over here, this one here, these two which you know about. So in this third rule, all we're doing is we're taking the k coefficient over here and putting it to the front. And if you ever have two functions over here and they're added or subtracted from each other, you can separate it into two integrals over here. Now, new ones over here. So first of all, if you have a definite integral with two terminals, a lower one of a and top one of b, if you swap them around, this just means you're multiplying by -1. So say if you swap terminals, you want to multiply by -1. So it's one way to remember it. Now for these, for this top one and bottom one over here, the first and fifth rules, these ones can be analyzed a little bit more visually. So if we were to have some sort of curve on the Cartesian plane, so our x and y axis over here, this is our curve. Now remember that integration is actually really handy for analyzing the area underneath the curve, and this is saying that we want to, when we approximate the area underneath using rectangles, it's simply saying we want an infinite number of rectangles. So, for example, going from, let's say we have a midpoint as well. So we got a bottom terminal of A, top terminal of B, it's midpoint here of C. Now, what this is saying over here is, now we'll just look at the last rule over here first. If you ever have the integral from A to B, this part, so this first integral here, actually gives you this entire area. But what happens if you split it up into two parts, and you split it up into two parts dictated by this vertical line, x is equal to c? Now if that happens, then what you actually end up with is, well, first of all, this part, the integral from a to c, is actually this area. And if you have the integral from c to b, this gives you your second area over here. And of course, if you sum up the red and purple areas, you actually end up with the yellow area that you began with. So that's the fifth rule. So for the first rule over here, what does it mean to integrate from x is equal to a to, well, the same value of x is equal to a? Well, what this really means is what happens when you want to find the area of one vertical line. So this vertical line being x is equal to a, this one over here. Now if you find the area of a single line, then this means that you actually end up with, well, the line is two-dimensional. That means the integral from a to a dx is 0, because we know that the area of a two-dimensional line isn't really possible. And if you're trying to visualize it, you're pretty much squishing a rectangle until it's as narrow as this vertical line over here, which gives you 0 square units. And so we're going to use these 5 rules over here to help us evaluate some definite integrals in the examples coming up.